Hi, Will from Fologram here. In this tutorial, we're going to go through some common issues that you might have working with Grasshopper and Fologram, perhaps for the first time or when you're just learning the ropes, and make sure that those mistakes are recognized and you don't sort of come across them too often. So there's a couple of things here which are worth thinking about. One is because Fologram streams mesh geometry from Grasshopper to the headset, it can be very easy when you're animating models, for instance, to create a really large buffer of geometry, which is it sort of delays the appearance of that geometry on the headset. So you really want to make sure that you're only sending over data which you're seeing pretty much straight away. If you notice that there's a bit of a delay between what you see in Grasshopper and what you see on the headset, it's probably because there's a backlog of stuff on the server that Fologram is still processing, and you either want to send fewer polygons or at a slower rate in order to keep things synchronized. Just because as that buffer builds up, if it gets larger than the memory on the headset, you're going to have a bit of a crash time. So that's one thing to consider. So this can happen if, let's say, you're animating a robot model, the model might have, if you're using KukaPRC, the mesh geometry, for instance, in KukaPRC, which is a robot visualization plugin for Grasshopper, it's pretty light. So just animating the robot, if you're sending the robot geometry over, 10, 20 times a second, that's not too bad. Though we found often that people will model tools that go on the end of the robot, which are very, very, very detailed, and that can cause that buffer to build up when perhaps you don't need to see so much detail in your mixed reality environment. So just be quite careful of those things. Another common cause of issues, if I jump on here and get my headset connected, is, and this is a common thing, let's say you're wanting to create a modeling application with the track drag component. So let's say we make a mesh sphere, transform it with the chain of hand positions. There it is there, and send those meshes to the HoloLens. What's going to happen here is every single time the drag component updates, which will be whenever I move my hand, if you go through the Grasshopper workflow, what's actually happening is this entire list of transforms will update, which will update this transform component here, and it'll resend every single one of these meshes to the HoloLens. Now that can get pretty chunky pretty quickly, and I'll show you what I mean. So as I draw, to begin with, pretty fast, and very, very quickly we start getting a lot of latency on the headset and a delay between what is being updated in Grasshopper and what we see on the headset. And that's just because we're sending over more and more and more data the longer that we're dragging. So what you would want to build in this case would be to only send over the most recent sphere and not all of the previous spheres. And this is really just a Grasshopper data flow exercise. So to do that, one nice way of, a very, very simple way of managing these kinds of issues, which will come up quite often, is rather than sending through this list of geometry in Grasshopper, you can either use these more advanced components, which we'll cover in later tutorials, to only send over the most recent bit of geometry that you're creating, or you can use the Rhino document as a kind of a buffer. So if we bake, I'm just going to make a button. And I think this bake component comes with human, which is a great plugin for Grasshopper. If we bake the output of our mesh spheres straight into Rhino, rather than using the send mesh component, that can be a pretty good way of only sending through the most recent sphere position, rather than an entire list of spheres, which isn't actually changing. You need to be a little bit careful though, we don't want to bake this whole big list of spheres, otherwise every time this track drag component updates, it'll bake 164 spheres, we don't want that. So let's just use the current hand position and just bake one sphere at a time. So now, as I draw, you'll notice we just don't get that same latency problem because Fologram is only sending the current sphere and not resending all of the previous spheres. And they're being saved straight into Rhino. Now, if you want to work with these inside of the Grasshopper, your typical Grasshopper workflow, you can, but you'll need to use some of these more advanced components. One other issue that you might come across when you're working with Fologram for Grasshopper for the first time is if you're switching between lots of different Grasshopper documents or you're starting and stopping the server, sometimes these components don't detect the events being registered on the headset. You can force them to update by refreshing your Grasshopper solution, so hitting F5 or clicking compute up here, recompute. So if you recompute the solution, that'll just update everything, and hopefully that fixes the problem. If it doesn't, you can try restarting Rhino and Grasshopper.